All right, so here I am recording lesson 11 of Unit 4 with my favorite class, recording it for my least favorite class. All right. And Will and Sam, quiet back there. Now, so you just looked at Mr. Fox's video introducing the point of intersection and how nicely our TI calculator can tell us this point of intersection. And we also see that if we graphed it, we could prove it is by substituting one of the values into each line and see if you get the other value out. That line exists on both. Now, what we want to do here is, the goal of this lesson is to see how the point of intersection can be used in application problems. Now, here we've got like a very simple business situation. And this is where linear equations and points of intersection can be very, 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 very useful. So often you'll find that, actually I'll get to this little point later, but let me just read this question. Here, we've got Amanda's little sister. She wants to run a pet sitting business to make money in the summer. And she's figured out two different ways that she might charge her customers. She's thinking that she might charge them 75 cents per hour per pet sitting. I know that sounds like not much, but maybe she can get 15 pets in her backyard, so she's making a lots per hour. Well, she can maybe they amuse themselves and she sits in suntans and listens to her music. Well, these dogs and cats run wild and chew each other up. But, so, she's wondering if she should charge 75 cents per hour, or $0.75 per hour, or if she should charge a flat rate of $4, meaning no matter how long the pet's going to stay there, she's at least getting the $4 plus 25 cents for every hour they stay there. So there's these two different options, and she's wondering what will work better for her.
What's the last word on there?
Which one?
Is application
Problems. Sorry.
I do the first one.
Now, well, this is where math can show us which one is better. Because a lot of times in business, there's some smart mathematicians along with some smart English people who can pose a problem that make you think you're getting the better deal and it might be the worst. So let's actually look at how this works out. So you don't want to be a poor mathematician and have people take advantage of you.
I do the second one.
Now, if we're looking at this, remember that if we have if we want to graph this, remember on the horizontal, people, on the horizontal axes, we put the variable that won't change, that we can't change, it's independent. So what depends on what? Look at what they're talking about here, and what do you think we would let x represent?
Hours.
Yes, so we would let x represent time, which is hours in this case. So let x represent
Hours.
the number of hours pet sitting. What do you think y would represent then?
Money?
The money. And in this case, it would be the charge. The charge in dollars. Jerry Maguire,
Yeah.
show me the money. Now,
Yes.
are these two different options that she's weighing? That's what it is, right? It's two different options. So let's look at option one and see if we can come up with an equation. What's her equation? Y is the dollars. It's the thing where she's just going to charge a flat rate of $75 per hour. Watch when you ever see something per something. That is a rate. So what is it telling us? We're dealing with straight lines. Rates are. What's another word for the rate? What are we talking about? Slope. So this is the slope. So option one is $75 per hour. What do you think the equation is then?
Oh, 0.75 over 1.
Over 1, yes. Times what? What's the equation of a line?
0. No. Oh.
Y equals mx plus b.
Starts at
This is the
4.
m.
Starts at the origin now.
It does. This one is a direct relation.
Oh.
But if it's y equals mx plus b, it starts at the origin, so b is 0. What's the other thing missing in this equation? Y equals mx plus b. We just said what m is. Yeah, I need x there. So option one is 75 cents per hour, or $0.75 per hour. We left it as a 0.75 because we said let y represent the charge in dollars. So option two, y is equal to, what would it be?
0. No.
25
No. 25. No.
plus
0.25.
0.25.
0.25x plus 4.
You got it. Because no matter what, so this one's starting at the y-axis at 4. Now, which one has, I'm going to just erase this little graph and do another one in a sec here. Which one, I'm just going to sketch this roughly. So one's going to start at 4. 1, 2, 3, 4. And the other one goes through at 0, right? It's a direct variation. Which one has the steeper slope of these two? Option 1 or option 2?
Option 1.
Option 1, it's actually like 3 times as steep, isn't it?
Yeah.
So, and option 2, so would this be correct? That option 2 has a more gradual slope than option 1, but it crosses through the y-axis at 4. So, can you say it's something like that?
Yeah.
And that's option 1?
No.
And is the other one a steeper one?
Not
So,
option 2.
that's option 2.
Not 1.
It's not 1. Why did you say 1 and make me write 1? Bad person, you.
The face. Just like.
2.
Just like it didn't have
That
a
was
face. It was just-
Sam Baker for everybody out there. Now, the other one goes through the origin but is steeper. So could that be option 1?
Yeah.
And this will be the point of intersection? So we know they're going to cross, right? Do you not logically know they're going to cross? Because the less steep one is above the steeper one. They got to cross, right? The less steep one is above the steeper one, so they got to cross somewhere in that, what we call the first quadrant of the XY plane, or the positive quadrant. So that's the point of intersection, and it tells us something. So if you were to put this into your TI calculator, so if you were to go change your TI calculator and put these two equations in instead of the two you had, could somebody do that really quickly? I'm going to pause this. Okay, Jaden with her lovely pink calculator got that the point was 8.6.
Yeah. With flamboyant calculator.
So TI gives 8.6 for that point. We call that the point of intersection, the POI. All right, so 8.6. This is what this tells, and this is what Will noticed right away. Will said, let me just get my little laser pointer out here. Will said, if you're staying a long time, pick option 1. If they're going to stay a long time, this is what Amanda's sister would do. Obviously, the person dropping them off wouldn't want this, but Amanda's little sister would like to charge them option 1 if they're staying a long time, and then Will said charge option 2 if they're not staying long. Why articulate that? Why is that?
Because
You are
option,
basic $4.
there you go, buddy.
What's that?
Because option 2, like, it's better if it's short because it gives you the immediate $4.
Yeah.
So if they're gone for just an hour, you've got $4.
Yeah.
But if you got this 0.75 and they're gone for an hour, you only got $0.75.
Yeah, I know.
Calm down.
Very good. Could I say it this way? At any particular point in time, like let's say right here at this point in time, do you want to take the option that's higher up? Because the more high, like look at, if they're only going to stay whatever this is, like 3 hours or something, you want the option that's higher up because that gives you more money. Do you see that it's higher up on the Y scale? And the Y scale is dollars. But you see over here, like if they were staying 12 hours, option 1's higher there, right? So the point of intersection tells you where things change. Your situation changes, which is what Will said. So if it's, if it's to the left of the point of intersection, they're not staying long, go for option 2. If it's to the right of the point of intersection, charge them option 1, you'll make more money. Does it matter which one you go with at the point of intersection?
No.
No, it's the same amount of money. So let's write that up. So we can say if she sits,
Why don't they just say Amanda's little sister's name, not?
I know, wouldn't that have been nice? We should go back and change that. If she sits for 8 hours, both pay the same. If she sits less than 8 hours,
2.
option 2 pays more.
Wait, why does it say she's sitting?
Pet sitting. It's pet sitting.
I thought you meant like sitting on something.
Yeah.
Yeah, but like you.
I'll warm up that seat over there for a solid 8 hours.
Yeah.
If she
Imagine sitting
sits
for
greater than 8 hours,
Ronaldo told me to, so.
option 1 is better.
Dude, I think I did dogs later when I was in sitting dogs. It's not fun. It would be.
So this can tell us a lot of stuff. It was kind of neat. It can tell us some good information. So just while everybody catches up writing, then I'll pause this. So here in example 3, we've got more of a business situation. Now, in the business world, companies have what they call revenue. Revenue is the money you bring in by selling something. Whether you're selling something physical, like a car, or a wheel, or a baseball bat, or something like that, what you charge people for that is what you bring in. However, you also have costs. You have to pay an employee. You might have to pay rent on the factory. You've got to pay for maybe a lease you took out on all the equipment that you make the baseball bats with. And there's all the workers there. You also have to pay maybe a lease for all your technology that you own per month, all the computers and everything that people use, and the printers, et cetera, et cetera. So all of these things are costs. Your profit is revenue subtract costs. So you got to hope that revenue is going to be greater than the cost so that you actually make money. So this is where the point of intersection can be very, very important. There are a lot of people in business that don't do this good math beforehand, before they open up a new business, and maybe they also didn't survey things right. Because how often do you see, maybe in a small town like Port Hope, where somebody might open, the Northumberland yoga and tea shop? So they've got this place downtown where it's a yoga studio, and after you could sit and have a tea and maybe a muffin or something, and they might sell the odd little Lululemon type stuff and that. But they did not do good analysis ahead of time, surveying people or whatever. People based it on, I just love yoga, I'd love to quit my job, be my own boss, I'd like to work at what I love, and they take all their retirement savings and they go do something like this. But what they didn't realize is their costs, renting that building, paying the utilities, paying somebody at the cash, paying the yoga instructor, all of these different things cost quite a bit. And maybe they don't get enough people in per week or per month that the revenue they bring in doesn't overcome their costs, and that they actually make money. And you see these little small businesses that sometimes in less than a year or 2 years, you see an going out of business sign, and they're gone. Because people didn't really have the smarts, they didn't know the math, and they didn't also have a feel for the community if the people wanted their product and that. So anyway, so here we've got Alex, and he's got this little business that he does on the side of selling printed t-shirts. So maybe he's got funny little sayings, or he takes pictures, or might do it for a sports team and put their logo on it, but he makes these t-shirts. He had to initially pay $195 for the computer software. Think of something like Photoshop or something. He had to buy some computer software to do his graphics up, and he also needed a printer, okay? Have you seen, like at Staples and Walmart, you can buy those inkjet transfers that you can iron onto shirts? Yeah. They don't cost that much in that. But anyway, so you can buy those. Now it also costs some, so that's what he needed up front. He had to pay $195. Maybe he already had a computer, or his mother's loaning it to him or something. So he just needed this additional money. He already had some other stuff. But it also cost him $750 to make and print each shirt. So maybe in that $750, the t-shirt might have cost $6. The actual transfer to iron it on might have been $1, and maybe he puts 50 cents towards knowing he's going to run out of the ink for his computer, for his printer. So each shirt costs him $750, but he sells them for $15. Let's see if he's got a good little business and see if it makes sense. So what will X represent here? What depends on what? What will X represent? If you think of the X, what is it? He's not like charging things per hour. What's he charging for? Sure. So X will represent the number of t-shirts made or sold. So the number of t-shirts sold. So what would Y represent?
Cost?
Yeah, the cost in dollars, okay? Now, because things are all either a cost to the company or revenue that you come in, you should be able to come up with an equation for each. His cost and his money income. So, what are his costs? How could that be an equation? Y is equal to what? You should be able to get it out of those 3 sentences or whatever that are above. One of them actually says it costs him.
750x.
Yes, because it costs him, as we see here, it costs him $750 to make each shirt. Plus that $195. You got it. So it's 7.5x, because X is the number of shirts, but there's that initial money he had to put out to get the software and the printer. So his costs, he's got to go buy the shirts and the transfers, and maybe restock his ink and that, plus there's that initial cost of $195. Now, what would be the equation for the money he brings in?
15x.
That's it. 15x. $15 for every shirt sold. Now, I won't have you guys fumble around on your TI. Because we would actually here have to fool around with our window to get this right. Maybe I'm actually going to do this on the side. If you were to get this on your window, we don't need the negative part of the x-axis because we're not going to make a negative number of shirts. And we're not going to do the negative part of the y because you don't charge a negative amount of dollars. So I'm just going to write this on the side. If I was to do the x min on my calculator window, I would do 0. Would that make sense? Now my x max, you're kind of guessing. How many shirts do you think he breaks even or makes money? Just guess, maybe. You might have to go back and change this, but I'm going to say 40 maybe. 50, we can say 50. And the x scale, I'm just going to, if I'm going from 0 to 50, I might put it up in 5s. Now the y min is going to be 0. But what do you think the y max might be? How far up it might happen before we cross things? What is one number that we already know on the y-axis? No, that's an x value. Where does the cost line start on the y-axis? Where does it cross it? What's the y-intercept? So we're going to need a y max bigger than 195, right? So we're going to kind of guess a little bit that it might be like 200 is too close to 195, right? So 300 or 400 or 500. I might put 400. Maybe I'll put 500. And therefore my y scale, the scale, I might go up by 10s for the scale. Does that make sense? Because remember, you've got to be able to see this in the window. Anyway, if I were to put this into my calculator, do you know what the point of intersection is? I'm going to have to put it right under here because I don't have enough room. It's 26,390. So that is going to cross, it tells us in both situations, or it tells us that the point of intersection is 26,390. So how many shirts does he have to make to break even? 26. So at 26 shirts, he finally breaks even. So what does the point of intersection tell us? It tells us that he breaks even when he sells 26 t-shirts.
What does it mean to break even?
That your costs for running your business equals the amount of money coming into your company. Now, you've got to hope in the amount of, like, your cost means you're getting paid, right? That's part of the cost of your company, that you're getting paid. So you at least want to break even. It means you're not going in the hole, you're paying all your bills, you're paying all your employees, which you're one yourself, and you've got enough revenue. You'd like to do better than that, wouldn't you?
So you get more.
Yeah, so if he can sell
More than
50 t-shirts, like it says here, he's going to start making money. So if this was a summer job, he might have to think over the 2 months, am I going to be able to sell going around to people, being at the Coburg Beach and places? Am I going to be able to sell, maybe going to baseball teams and soccer teams, and maybe they want a t-shirt for warm-up or something? Am I going to be able to sell more than 26 shirts? If I can't, I shouldn't do this. Right? You know what I mean? That's being mathematically smart. If I don't think I can sell 26 t-shirts, I'm not going to do this. And not enough people look into that. So would Alex make money if he sold 20 shirts? And then it's no. Would he make money if he sold 50? Yes. So hopefully, if this was a summer job, he would have sold 26 t-shirts a couple of weeks into July, and he's got like a month and a half to make money. Buy himself that awesome hockey stick that's going to get him so many goals. All right, so that's the lesson.